Well, hi and welcome to my shop, and thanks for keeping me company here while I carry on with this radio. What I hope to do today is to verify that the alignment I did yesterday is valid and good, and I'm going to try to use some different techniques to see if that's the case. Something else I did already is yesterday I forgot to replace this capacitor and resistor combination here, which I had noted were in bad shape. There's the old resistor. This measured 80K, it's supposed to be 68, so I've just soldered in the replacement here. There we go. So I overlooked that yesterday. I don't think this would have any effect on the operation of the radio, though. Maybe a small effect on the tone, especially at low volumes. So no problem there. Now, what I'm going to do is stop for a while, get everything warmed up and set up, so that we can do this alignment verification I want to do. So one of the first things I need to do is figure out where a good spot is to connect my oscilloscope. My oscilloscope, like all good instruments, is high impedance, but still can affect some circuits in this radio that have impedances that are similar to the scope. And I think what I want to do is I want to monitor the output of the IFs, the output of this guy, and a very good choice would be on the detected line here. I could clip here. That puts my scope right onto the bottom of the coil and capacitor tank circuit here. I could clip past this resistor here, for instance, anywhere on this line before this 1 meg, but that would put my scope right onto the grid of this tube, and already the impedance in this line is getting very high. Look, at 2.2 megohms. So I have the feeling if I put it here, it's going to drag down this tube's operation. So another place is to come towards the volume control on the other side of this 50K resistor, to the top of the volume control basically, which is a very common spot. You get the benefit of a little bit of isolation here of the 50K resistor, and you can still see the DC that's being generated here, and you should be able to get a good look at the output of the IF right here. We're looking at it in RF, let's put it that way. The RF is it's an attempt here to snuff it out. We're not really looking at it in RF. Let me hook up the scope. Let me carry on. Stop talking and do something, Jim. Yeah, that's a good time to stop talking. Okay, so the good spot to hook up the scope is going to be on the other side of the 47 or 50K resistors, right there, out in the open, coming right from the terminal on the IF straight to the volume control, in behind all this stuff you can't see, but I'm going to be able quite nicely to get right on here like that. I'm not going to do it right now, the radio's not operating yet. As for the input from the signal generator, I'm going to be using the sweep generator right here. This is the output from it, and I'm going to feed it into the grid of the first tube right up here through this capacitor that I've got. So I'm going to do that. Again, I'm not going to have it like this when we first start up. I'll hook up the equipment and see what happens to the radio as I'm doing it. And so that will put a sweep signal into the very front end of the radio. Now I can make the sweep just through the IF, or I can make it sweep through the entire radio band that's over here. Probably do both in the end. So let me we can leave things running, I think, while I do this. Start that guy up. So first we'll set this to sweep through the IF. So that would be from, say, it's around 455. So let's say from 430. Set this to 430. Okay, so this is the start frequency of the sweep. Can't be seen on the camera. You can see that about good enough. Starting at 3, but we want it to start at 4:55 here. 4:22. No, not 4:55. We said 4:30. 4:30 is 25 below. Okay. 4:30. Okay, and then we wanted to set the stop frequency 25 above. Sounds like 480 to me. Okay, that's good enough there. 480. So if I turn on the sweep like this, it usually reports a number in the middle. Should be 455 here. Let's just check this. Did I do something wrong? Start frequency 430. Stop frequency 480. Well, how can 55 be in the middle of those two numbers? So 25 on top, this should be 490. 25 on top of 55. 60 is 80. 480. 25 below 55 is 30. What am I doing wrong here? Well, I'm not doing anything wrong, so I have the feeling it's just not report. Well, that's pretty close. Good enough. Yeah, okay, I get involved in fiddly little things sometimes. Great, but I think this is sweeping fine, but we're going to stop it right now. There'll be a single frequency coming out of this generator at that number right now. And the level's controlled here and here. You turn these attenuators on, and so there's really almost no signal coming out right now. Great. Now let's get the scope set up here. So I'm expecting quite a low voltage on this reading. We can start with maybe 1 volt per division. Now I'm using the sweep from this to sweep the signal generator. Scopes have their own internal sweep, and I'm not going to be using that. So we're going to set this that way to what's called the XY setting here. You can see it just stopped sweeping because the signal generator is not running. If I run this, you'll see the sweep moving here. And where to go? It's going really slowly. So I'm going to speed it up here. It takes about a second now to complete a sweep. You can see it's off center, and that's just what happens. I have to center it up. Okay, I'll do this a little better if it's sweeping faster. So I'm going to stop and a start and trying to get them right in the center. Get them balanced. There we are. So if that's 430, 480, how do you get 455 in the middle of those two numbers? So the center should be 455. Probably if I wrote those numbers on a piece of paper, I'd answer that question. But, okay. So far, so good. Now, we normally would have this sweeping a lot faster. Sweeping like that, so it looks like a continuous line. So this is a lower frequency, this is the higher frequency, and the center's in the middle. Hey, center's in the middle. So we're all set there. We're all set, really, or set to see if I know what I'm doing or not. Okay, radio's off. Everything's ready. Okay, dim bulbs in. Radio on. No equipment's connected to it yet. We'll just get the radio playing. Oh, this thing may act like a bit of an antenna sticking out here. When I connect the signal generator to this, it should quiet the radio quite a bit. Basically, I'm shorting the antenna out with this. Okay, let's just take a shot at getting that French station. I may not be able to because the antenna may not be aimed correctly. Okay. bit of a mind of its own. Let me put it on full power here. Okay, did that help? Shouldn't. No sign of the French station. Okay, well, we don't care about that. I'm going to tune the radio. I think I'm going to tune it down this way. To the supposed quiet spot. There is no such thing. So, no, that sounds like a real quiet spot, but actually there's a strong noise signal in there. I'd like to just pick up atmospheric noise. That's not going to happen though. Well, let's carry on. Let's stick it there. I have no idea how quiet that is. So we'll start by watching what's coming out on the scope. So this guy is hooking up to here. Okay, no effect on the radio at all. The scope image disappeared. It's down here now. So what's happened is there's a DC voltage there, which we can watch. Can you see this? Let me just change the lighting here. As I tune the radio, you'll see the display kind of bop up and down. It should. Yeah. So in fact, when I'm here with the display down, it's indicating there's a strong ABC voltage and a strong carrier, noise sourced carrier in there. So I really want to find a spot where this is kind of riding up there. Look at how unbalanced that signal is there. How high can I get? There's just a noise signal generating some ADC everywhere in this radio. Holy smokes. As noisy as that sounds, that's about the best spot right there. Okay, now I'm going to connect the signal generator with no output, and it should just quiet the radio. But just take a notice that this is all downwards. There's nothing going upwards. That's a little odd. Don't know what it means. Here we go. Okay, so we got the radio quieted down. Now you can see quite clearly there's all this stuff down below. What is all that? Let me turn the radio up a bit. So that's what we're hearing. Why it looks like it's... Well, it should look like it's rectified, because it is rectified. It's the rectified output of the IF with most of the RF removed. Or all the RF removed. Great. Perfect. Now, let me turn up the sweep and we'll see what happens here. We should start hearing it. Well, there's the shape. I turn it way up, you can hear it. You can make this less sensitive. So we're looking at the response curve for the two IF transformers in the radio. Looks fairly good offhand. But let me recenter this. I'm watching the two ends. It's very close to 455 on here. In fact, I'd be more inclined to doubt this position than to doubt that it's 455. But we're going to prove that in a bit. So I can affect the position, size, and shape of this curve by adjusting those transformers. And when I look at this, I see it steep here and then kind of a not so steep tail. Doesn't look like it's very well balanced. Plus, I really want to know what's happening in terms of, is this really 455 right here? And that's the first thing we'll do, is I'm going to connect a second signal generator. There it goes. Okay, and I'm going to feed in a single frequency, and as I steer it through here, we should be able to identify the exact frequency of this point. That's the scam. Okay, let me get. Whoops! Lose everything here. So this is the second signal generator. We just want it in with the first. So I need to attach the ground here somewhere good. This is a good spot here. Good. Go up here. This may quiet the radio a bit more. Oh, what do we hear? So, interestingly enough, I think I have the radio tuned to 600, and I got 600 coming out of that signal generator. And let's just look at the scope there. I'm going to turn off the DC sensitivity here, so it just shows the AC signal. It's a curious thing. One of the things I can see here is, as this signal moves across, it widens out a bit. I don't know if you can really see that. Pretty hard to perceive, I think, on the camera. But so you can make the sweep go linearly, which is what I've got now, or you could change it to logarithmic if you wanted. What happened there? How would pushing this button? So I push the log button here. My understanding is it changes the sweep to a logarithmic sweep, so it'll be slow at first and then faster at the end. Didn't seem to do that at all. Okay, so maybe this sound we're hearing is overload. Maybe I got too much signal going in. So now we're just left with the signal generator over here. Let me correct this and get this off 600 so we're not hearing it. Okay, so we're down below 455 now, kind of out of the way. So now we're just back to this one. Okay, no answers to those questions. Now, so I'm going to steer this signal generator across 455 and watch the scope carefully. You should be able to see a little sort of an interference pattern or a squiggle as it comes through. Okay, so I'm adjusting it now, and I'm watching. We're coming up on 450, so I'm watching for something to happen. It happened, but you couldn't see it, but I saw it. Something went right across here. I'm going to give it more power. You'll be able to see it now. So we're going to come from the top as I turn the frequency of the second generator down. We're watching for something right in here. Here it comes. And then past. So we just got to this maximum spot here. I'd say that's it there. Da, da, da. 455. Now, yes, it says 454. I'm one number off on that. It's exactly 455. So what do we know? So we know we've got the right frequency. Have we got exactly the right shape? So I'm going to adjust the scope to force this onto the center line so I can't lose track of it. You know, there's another way I can do this actually. Let me do it another way. Center up the scope again. I'll change the start and stop frequency, and that'll cause this to move around on the screen. And that'll bring it 455 right in the center where I can't lose track of it. Okay, I get rid of the this is called the marker generator, even though it's not putting a mark. So there we are. Funny shape here. Now I'm going to start twiddling the adjustments on the radio a little bit, and we'll see what we can do to the shape of that curve. How important is this to the sound coming out of the radio? Probably extremely subtly important. So which one? Where'd that noise go? The noise coming and going. I don't know. Okay, there it goes again, coming and going. It's probably something in my shop making that sound, making that interference. Wow, it's the magic rod. Nah, it doesn't work. Oh, it did work. So in case you're wondering what am I talking about, I'm talking about the little sparky sounds that are coming. That's a terrible word. Those ones. Those. And then they disappear. Oh, the strangeness in radios. Okay, that's got to be something going on around my house. Now we got to decide which transformer do you want to try to monkey with first. Probably the second transformer, since it's closest to the output. I'll be the one to start with. Okay, so I'm just getting my tool in here. Bottom of the second. I don't want to turn this. Well, it's okay. Come on. So how do I got? Great alignment tools here. There, got it finally. Wow, that took a lot. Okay. Now watching the shape of the curve and how it varies as I turn this. Okay, so you know what? It got a lot better. So you can imagine there's actually 4 curves here for 4 adjustable transformers, one on top of the other. And if you look close, you can see the individual curves, kind of, or the effect of them. So I'm going to swing one of the 4 curves this way, and then the other way. Can you see it's right here? Right down at the bottom here, and I'm looking to make this as low as possible, while retaining a reasonable shape and keeping it close to the 455 mark. I'm guessing I never quite got this fully centered up. Cheating now. There, now it's right on. Okay, that's one. I'm just going to do the top of the same transformer here. Okay, watching the shape again. You can kind of see it's a little bulky on this side, and I rotate it, and it's kind of bulky on this side. So it goes back and forth. Okay, just using my artistic abilities. And now we want to go to the first transformer. Let's see about that one. I can really see a knee open up in here. I'm just trying to make it look pretty. That looks nice. Notice the top is getting less sharp and more rounded or flattened, if you like. That will affect the sound quality of the radio quite a bit. Sync. Okay, let's do the top of that one. It's quite clear where that one has to be. right there. So when I look at this curve now, to me it looks very symmetrical. Looks really nice. Okay, that's fantastic. And we're right on 455, are we? Let's bring in the 455 marker generator again. Okay, so I'm going to set the generator at 455, right about there. Right in there. I'm varying the generator a tiny amount here. Well, it's about 1,000 hertz actually. Right on the money. We're good. So this to me verifies the IF is very well tuned now. We should listen to the radio or have all this equipment connected. Why don't I carry on with the front end tuning? So we're looking at the output of the IF. The front end tuning, I think we can get away with it. I think I can feed a regular signal into the antenna. I'll do it with a loop on the generator, and then we'll look and see what this looks like at the IF output. Okay, let's try that. So I'm going to leave this hanging here. I'm going to disconnect from it. Okay. Now, sweep generator, we want right on the, we want to feed the sweep, we want the sweep generator feeding the loop antenna. Oh, I can't. Oh, okay, gotta take all this off. First I gotta take this off. I gotta take these two off. Okay, so I want to put the scope one back on. Interesting, it quiets down the radio. Think about that for quite a while. And this is the other signal generator. I'm just going to remove it. Well, it's even more interesting. The scope ground doesn't do it. Ah, okay, put on the list. Put it on the list. Now we'll take our loop. And we're going to put this near the radio antenna here. Like that. So here, like that. And we want to sweep the frequency the radio is tuned to. So there's quite a bit that comes through here in terms of the shape we're going to see. It's more curves on top of curves. So we're going to set this radio near 860, near the French station. I'm going to go a little further, 900. So it's around 900. Something like 900. I want this to sweep through the 900. We'll stop it. And we'll start it at 800. That's easy. I only think the radio's tuned to 900. 800 and then 1,000 at the other end. Okay. Started sweeping. Maybe we should start hearing it. And more power. There it is. Here it comes. There we are. So what's happening now is every 10 milliseconds the sweep goes through, crossing the frequency the radio is tuned to. That should generate a response. I disconnected my scope here. That should generate a response in the detector like this. It's a very, very strong response. Let's turn this guy down a bit. Ooh. No, we'll turn the scope less and less sensitive. Wow, that's a 20 volts per division now. Oh my gosh. Tune the radio a bit, that should move. Tune it all the way to 800. Oh, what's that? Not sure what's happening there. All the way to 800 should disappear. And then all the way up to 1000 should disappear again. Okay, good. So this should be 900 or so. I don't know what that is. Some other interfering signal. Some funny stuff right on the edge here that moves around too. Don't know what all that is. Shape has really gone kind of cockeyed in there also. Okay, what are we doing now? So we're going to try to adjust the front end tuning to create the strongest IF output. The shape of it, I'm not so sure that's important. Here we go. Wish me luck on this. So first thing is stay away from the oscillator. We're just doing the intermediate, and so what happens there? Not at all what I would expect. So I think the response curve is over here. So I want to get it on top. Can't get there. Can't get there. I can't get there with this one. Okay, I'm going to turn it back a little bit. This is kind of what I was muttering about yesterday. I'll try the other non-oscillator adjustment here. So I'm going to open it all the way. It appears to make this kind of come balanced. If I close it where it kind of should be, looks like it's all happening over here. So why don't I move this over here where all the action is? I could do that with the local oscillator. Okay, this is going to mess up the alignment in terms of the official alignment. So as soon as I do this, I'm on my way to... Oh, this is great. Okay, so now what I think I'm doing is I'm putting the local oscillator within the range of the two trimmers. Something I tried yesterday and just couldn't kind of figure out. Ooh, what's that? Well, we could sit and analyze this for quite a while. Just swinging the local oscillator back and forth. It's going in and out. Let's just put it like this. Make this peak show up here. Is this one of these? Is this the intermediate? Oh boy. Oh, maybe this is a signal. This is like a noise signal. Let me tune the radio a bit. Yeah, you know what? This is some noise that's right in the area where I'm doing this. Let's move it over here. Do I know what I'm doing? Barely. I barely know what I'm doing now. Okay, oscillator. Just put it in the middle of that thing there. Intermediate. Make the curve look nice. Antenna adjustment. Goodness knows I shouldn't be doing this one. Sure I can. We're feeding it in through the antenna. Okay. Well, you know, looking at it visually and just trying to make things as symmetrical as possible, that seems to be about where I get. It's just a bit of a funny little jog here. Let's see if I can get rid of that. So this is the oscillator being adjusted. I bring it over here a little bit, and then fool with the two trimmers here. a sort of a similar result there. Still has a bit of a like a knee right here. Okay, it's not much else to adjust. Could fool with the IF. The IF. Yeah, let's mess this radio right up here. I know somebody who can help me fix it later. Okay, going on the second IF coil. Watching the shape now. Oh my. Oh my, what happened there? So we tightened this up here and made this extend downwards more. So very seldom do I go back to the IF tuning. Usually I tune the IF. I follow the instructions, right? Tune the IF, then tune the rest of the radio. You know, and again, as I've mumbled in other videos, maybe that makes sense in a radio that's still in the factory. But maybe when they get out to my shop, this is the other IF coil. So just by turning all these things, sooner or later I get a real nice shape, tight at the top, straight sides, not so flat at the bottom yet, nice and neat. I think we need to listen to this radio at this point and see what's happened. What has happened? Okay, so the equipment I've got connected to it shouldn't interfere with its operation at all. I'm just going to quell the sweep. You can still see it there. There. Now let's listen to this radio. What have I done to it? Okay, stations anytime now. There's a voice in there. Let's go back to where the voice was. Okay, I'm going to remove the equipment here. It's interesting. Pull the ground off. Just go try and get rid of this extraneous antenna. Hey. Oh! That's what you got to do. You got to hold this capacitor. Excellent. Okay, let me get it out of there. The whole time this capacitor's been there, has it been just by hanging out here? Has it been throwing things off? I think I can get it out without anything terrible happening. Yep. Okay, set it down. 590. Now, let's tune around, see what happens here. Terrible heterodyne there. Sounds nice, except for the heterodyne interference. Okay, here we go. .680 seem to be missing. Come on, French station.
Ce d'autochtone de l'Université du Québec en Abitibi-Témiscamingue, Sébastien Brodeur-Girard, l'heure n'est plus aux analyses, mais à l'action. Les constats sont posés depuis.
Well, there's some marks on the front here. They're marking different frequencies, I'm pretty sure. I think this first one, just one second. I think this is 1460. This is probably 1 second here. Just 1 second. Probably 600. That's the end of the pointer. This is probably 600. Okay, let's find out if it is. I'll take the single frequency generator, feed it through this coil into the radio. Let's see what we got. $570. So you know, what I'm doing here is I'm kind of discovering that my desire to make the pointer point accurately at the scale may be an error with these old radios. And maybe what I really should be doing is doing what I just did now, peak them for performance and don't worry so much about the pointer. And maybe in the end, if I really had to, I could cheat the pointer on the string to make it accurate in the spot I need it to be accurate in. I think that's the lesson I've learned. Boy, it's taken a lot of radios to kind of come around to this. You know, it's like getting in a car and slamming your foot on the gas and then the car goes up to 105 miles an hour and you say, well, I guess that's what this car is good for. But for all you know, it has bad spark plugs in. Could go 115. How do you know? You have to get another car and compare it. And I wouldn't recommend going 115 miles an hour anyway. Okay, but I think I'm really doubtful I can, you know, eke any more out of this radio. Great. I think it's good. I think that's it for today too. I think I'm gonna not put it in its cabinet right away. I think give it a little more time to think about it. I'm very familiar with this radio now. It's a good one with that extra tube right in the front and the 3 stages. That makes this a really good radio to mess around with. Well, I think that's it for today though. So, thanks so much for joining me for this, and we'll see what I'm up to tomorrow. I may have a totally different radio in here. I'm thinking about really shifting gears hard in my shop. See ya.